Welcome to the Bentley Systems training course to learn how to model slabs and foundations in the RAM structural system RAM Modeler. Over the next series of videos, you will learn how to model slabs and foundations in the RAM Modeler, which will include the process of modeling slab edges and openings, defining your slabs and decks, and then assigning them to the model. You will also learn how to model spread, continuous, and pile cap foundation systems. Slabs, slab edges, openings, and penetrations are defined in the RAM Modeler and are used by RAM Structural System for several purposes. First, for the gravity design, the extent of the slab, the tributary area, and the orientation of your slab will be used to determine your composite steel beam section properties, the gravity load distribution, and the live load reduction parameters. Once you get over to analyze your lateral framing system, the extents of the slab and the slab assignments will be used to specify the diaphragm boundary and the diaphragm properties, including the effective thickness, Poisson's ratio, and the elastic modulus of your slab. Any column outside the slab boundary, considering your slab edges, openings, or penetrations, will be automatically disconnected from the diaphragm. In addition, the extents of your slabs will also be used to generate the seismic load cases and the wind load cases in RAM frame. For the seismic load cases, it will calculate the mass, center of mass, and the mass moment of inertia for each rigid diaphragm. In addition, the point of application of the seismic load, considering the specified eccentricity, is calculated based on the overall structural dimension from slab edge to slab edge. With reference to the wind load generation, RAM frame will calculate the wind exposure based on your overall structural dimension from slab edge to slab edge. The first step that we're going to complete to modeling our slabs in the RAM Modeler is to lay out our slab edges. Slab edges are typically laid out along perimeter beams, but they can also be laid out to form arbitrary polygons. The slab overhang is the distance from where the slab is laid out to the edge of slab. Gaps in the slab edge will result in an error in RAM structural system. It is important that when forming your slab edge, you do form a closed polygon. For this training, we are going to be assigning some slabs and slab edges to a model that's already been created in the RAM structural system. This model includes a variety of structural elements such as walls, beams, and columns. This model also contains 4 unique floor plans, and we're going to be laying out a slab edge on each of the layouts, starting with the first floor layout. After you select your appropriate layout, you are now ready to assign your slab edge. To begin, we will go to our layout toolbar and click on our layout slab icon. When this icon has been selected, you will see several additional tools become available to lay out slab edges, assign slabs to the model, and also define your slab systems. We are going to go ahead and at this point click on the slab edge icon. Through the slab edge layout mode dialog, we can enter a slab overhang, and for this level we will select 0 inches, and then we have a variety of different graphics modes for which we can use to add our slab edge. Now, as previously mentioned, RAM structural system does require that your slab edge form a closed polygon. And on this particular level, I do have a complete system of perimeter walls which will be used to define my slab edge. Since I do have a complete system of perimeter members, I can go ahead and use the whole perimeter button, which will lay out a slab edge around the entire perimeter of the structure. Now, for this particular level, I do have some structural members outside my perimeter walls, so I need to help the RAM modeler detect where the slab edge is. In the warning dialog, I'm going to go ahead and click OK. And then with my cursor, I can just quickly click on one of the perimeter walls in this model, and then I can see my green line appearing around the perimeter, which defines my slab edge. After you are done defining your slab edge on the first floor layout, we are ready to proceed to the other layouts and define a slab edge for those areas as well. In my Layout pull-down menu, I'm now going to go ahead and select my second floor layout. I can see that my Layout Slab icon is still selected, and I can quickly just click on this slab edge icon. For this level, I'm going to change the overhang to 12 inches, and on the layout I can notice that I do not at this point have a complete system of perimeter beams. So therefore, I need to use the Add mode instead. Once I click on the Add button, I can use my cursor to click at each corner point in my slab. First, I'm going to start with grid intersection G1, and then I'm going to click Add grid intersection C1, which defines my first slab edge. And then I'm going to proceed around the perimeter, clicking at each intersection, starting at C1 and then going up to C2 and so forth. Now if I right-click to return back to the previous menu, you're going to notice that when I was clicking around the perimeter, I was clicking in a clockwise fashion. That is because by default your slab edge is set up to the left, which means that as you draw your line from point to point, it's going to apply the slab edge to the left of that line. So a clockwise orientation would be appropriate. Next, we are going to navigate up to the third floor layout and repeat this process. To return to the previous menu, I can just right-click on my mouse, which brings me right back to the slab edge layout mode. I'm going to keep my slab overhang set to 12 inches, and this time I do have a complete system of perimeter beams, so I'm going to click on the whole perimeter button. And then I'm going to repeat this process for the roof layout. After modeling your slab edge, you are ready to model some slab openings, if applicable to your particular model. When you model a slab opening, please note that the deck will not brace the beam top flange in the vicinity of the opening. Steel beams will be designed as non-composite. Columns will be disconnected from the diaphragm if they fall within the opening, and any loading that is within the opening will not be considered in the design. For this training, we're going to be modeling a slab opening on the third floor layout. So the first thing we're going to do is we're going to select the third floor layout from our Layout pull-down menu. Now we can see that our Layout Slab icon is still active, and over in my Layout Slab toolbar, I'm going to find a tool to add a slab opening. Once I click on this tool, this is going to look very similar to laying out our slab edge. I can enter a slab overhang. I will keep that at 12 inches. And I have some same types of graphic mode options available for laying out a slab opening. Now just like a slab edge, a slab opening also requires a closed polygon. So if you do have a complete system of perimeter beams defining your slab opening, we can go ahead and use the in-bay command to model a slab opening in a particular location. Here I will just click within the area enclosed by the opening, and here you can see I've created a slab opening. In the RAM modeler, we can also model slab penetrations within a slab. Penetrations are similar to openings, but are designed for smaller unframed openings in which the surface loads will be unaffected. So therefore, penetrations will have no effect on the surface load distribution, and they will be ignored when tributary loads in areas are calculated. Just like openings, however, the deck will not brace the beam top flange within the vicinity of the penetration. Steel beams will be designed non-composite, and columns will be disconnected from the diaphragm. For this exercise, we will be modeling a slab penetration on the third floor layout. I can see that my Layout Slab icon is still active, and over in my Layout Slab toolbar, I'm now going to click on my Slab Penetrations icon. Here I need to enter the size and location of each slab penetration in my model that will be applied to the currently selected layout. I'm going to enter a height of 24 inches, a width of 72 inches, and I'm going to locate the center point on the floor at x equals 81.5 feet and y equals 52 feet. And these are in reference to the global coordinate system. Of course, x is horizontal on the page and y is vertical. Once you enter all the parameters, I'm going to go ahead and click Add, and I can see that my penetration has been added, and you can add as many might be appropriate for your model. Once you've entered all of your slab penetrations, we're going to go ahead and click OK, and now I can see a new penetration has appeared.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.